So let me consider the y motion of the particle now, and for the y motion we write down the corresponding kinematic equation. In component form we have got Vy is equal to Uy plus Ay into t, isn't it? Where Vy, Uy and Ay are the respective y components of final velocity, initial velocity and acceleration vectors. Putting the values, as we know, we are looking for a time when Vy becomes 0, so that is the value I have put here. Uy, that's listed earlier, Uy is equal to minus 9 meter per second. So I put here minus 9.0 meter per second plus Ay, acceleration y component 15 meter per second square. I put this value also 15 meter per second square into the time in question is says called t1 for distinction, and solving from here you show that t1 is coming out to be 0.60 second into significant figures. This is the answer of part A of the question. We conclude that at time 0.60 second, the particle moves parallel to the x-axis. So let us go for the part B of the question. We'll have a look at the question once again. They're telling us to find the time at which the particle crosses the y-axis. Now it is obvious that at the point when the particle crosses the y-axis, its x-coordinate becomes 0. So let's make use of this to do the part B of the problem on this right hand side. In part B, we are supposed to find out the time, let me call it t2, at which the x-coordinate of the particle becomes 0, because that is the point at which it crosses the y-axis. So for this, we shall consider the x motion of the particle now. And we recall this kinematic equation in component form, that is x coordinate is equal to x0 plus ux into t plus half ax into t square, isn't it? Here x is the final position coordinate, x0 is the initial x coordinate, ux and ax are the respective x components of initial velocity vector and acceleration vector. So here we put the values at the instant of crossing the y-axis. X coordinate becomes 0. Initially x0 was known to be 12 meters. So I put that value plus x component of initial velocity already listed 7 meter per second into t plus half x component of acceleration vector that was listed here in part A of the problem minus 5 meter per second square. So it is minus 5.0 meter per second square into t square. I'm getting a quadratic in terms of t. Let us rearrange it to write 2.5 meter per second square into t square minus 7.0 meter per second into t minus 12 meters is equal to 0. A quadratic, and you know the solution of this. I'm just applying it straight away and writing that the roots of t are given by, well, I'm writing, you just corroborate this one, 7.0 plus minus square root of, this is 7.0 square plus 4 into 2.5 into 12 divided by 2 into 2.5 second. You have done these things many times before, so I believe you can just do it yourself and show that there are two roots of t. One of them is 4.0 second and the other root is coming out to be minus 1.2 second. Obviously, out of these two roots, we shall not take the negative value of time and take up this positive value. So my conclusion is that the time t2 at which the particle crosses the y-axis, that time is 4.0 seconds. The answer of the part B of this question. We shall now move to the part C of the question. And in this part they are asking at which point does the particle cross the y-axis. You already found out the time at which the particle crosses y-axis. We shall now find the location of the point at which the particle crosses the y-axis. And that is part C of the question. So let me try to accommodate this one, making one more column on the right hand side here. And we shall now consider the y motion of the same particle. Because we are finding out the y coordinate of the point at which the particle crosses the y-axis. And for that, considering y motion, we once again write the kinematic equation in component form. Y is equal to y0 plus uy into t plus half ay into t square, isn't it? Just like this one, y is the final y coordinate, y0 is the initial y coordinate, uy is the initial velocity y component, and ay is the acceleration y component. So let's put the values. Y0, initially y0 was 18 meters, as you can see. This was 18 meters. So I put the value here, plus uy. Uy is minus 9 meters per second. So it is minus 9.0 meter per second into the time at which the particle crosses y-axis, already found out in part B, that is t2 4 seconds. Let's put this value here. So this is into 4.0 second plus half ay, acceleration y component, 50 meter per second square, already listed. So it is half into 15 meter per second square into time squared, and that is coming out to be 4.0 seconds squared. Complete the calculation and show that this is giving me y is equal to 102 meters. So once we know the y coordinate of the point at which the particle crosses the y-axis, we know the point P at which the particle crosses y-axis have coordinates of 0 meter, 102 meter, isn't it? The x coordinate of the point is 0 meters, y coordinate of the point is 102 meters. And that is the answer of part C of this question.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.